Hello everyone. Today we're going to be talking about RNAV and how to fly an RNAV flight using the flight simulator. For that I have created an operational flight plan from Tenerife Sur to Madrid Barajas. It's already old-fashioned, it's dated in 2019, but it will be useful for illustration purposes. Before actually going into the flight plan and going into the flight simulator, I would like to discuss a couple of things. So first of all, I would like to show this picture that I'm sure we've seen it, or you've seen it when talking about RNAV systems, PDN, and this is basically the flight management and guidance system, which is composed of a computer. It is composed by the multi-purpose control and display unit, in Airbus terminology, MCDU, which is the one we're going to be using, and we're going to be basically programming our flight in this MCDU, and this is going to go through the computer, and the computer is connected with the navigation display, the navigation database, which contains all the information about the waypoints, airport seats, starts, etc. And you're going to see that it's very easy, that it comes very quickly in the computer on board. And then it's also connected with the flight control unit. The flight control unit is the element you have in front of you when piloting, in which you can select heading, speeds, altitude as reference values, and this is engaged. This goes in the computer and is somehow connected with the display units, the navigation display, the primary flight display. We've seen that in when learning how to fly on a conventional basis, and it's also connected with the MCDU, right? So this is the first thing I wanted to show. Second, when we go to the MCDU, the multi-purpose control and display unit, it looks like this. You have on the top right, you have the so-called line select keys, right? We're going to be using the left and right. Okay, so left for the left 1, left 2, left 3, left 4, left 5, and left 6 on the left hand side, the line select keys on the left hand side, and R1, right 2, right 3, right 4, right 6, 5 and 6 for those in the right hand side. Okay, that's the first thing. This is going to be important because I'm going to be using those to introduce elements, right? Then we have the so-called page keys, how to do a direct program, performances, initialization, data, the flight plan, the navigate, the radio navigation page, the fuel, etc., etc., etc. So we'll go through this. A menu will pop up in the display, and we could use the left and right line select keys to modify the values. Then we have this kind of slew keys to move to the right, to the left, to move up and down, and then you have numbers, letters to introduce values, for instance for altitude, for velocity, or a given waypoint, or a given aerodrome code. And you see that whenever we press any of these keys, this comes in the scratch pad, right? And then by clicking in any of the left Lima and right Romeo keys, we will be able to change the flight plan, change our fuel, or whatever we need to change. Then we can also work with the clear and other specific keys, and we can also use this to allow the MCDU to let you introduce names via keyboard if that's quicker for you, or even to uncouple the MCDU. Okay, so that's kind of an overview of the different elements of the MCDU. And then another thing I would like to mention is a color code. Okay, there's a kind of color code. You will see in the screen that you have whites, you have cyans, magentas, you have some sort of amber or yellow coding, and green. Well, the white is just information that is providing you information on what type of, for instance, I don't know, in the center bottom you see return, proceed, is information to you to navigate through the menu, the type of values that you need to include. Cyan is actually information you can change, right? When you see something cyan, is typically something that you can change, a flight level, a cruise, a fuel, etc. The amber, yellow, is information that is required and is not there, or is warning you on something, a pop-up message to the pilot. So yellow is kind of already telling you that is a warning thing. For instance, in the top center figure, you have this kind of, I don't know in English, asterisks things. You have 2 in magenta and 1 in yellow. This is a speed altitude constraint. So the yellow thing, it's warning you that the aircraft, according to current performances, current data, is not going to be able to make to this constraint, to meet this constraint. Whereas the 2 magenta lines, or the 2 magenta asterisks, are telling you that the aircraft is indeed going to meet the constraint. Okay. Then magenta are things that the aircraft is calculating with the computer on board, and it's telling you that things are okay. And then green are things that have been somehow inserted or approved, and the aircraft is going to fly. So this would be a kind of color code for the MCDU, and it's useful because it's going to provide you information, because there are a lot of things you need to do, and this color coding helps. And now let me just go now to the flight plan. Okay, this is the flight plan. It's a very flight from Tenerife to Madrid, from Bristol to Madrid, on October 2019, a while ago already. And you will have something, I would say, similar to this. Okay, to this operational flight plan. And let's gonna review together a couple of things on this flight plan. Okay, here you have the company, Iberia Airlines, flight plan, call sign, and origin and destination airport. Here you're getting information on the units, kilograms. Here is the date and the hour, right, of the flight, when the operational flight plan was prepared, and who did prepare this. In this case, this is of course not valid for flying. So we have a fictitious company and a fictitious user. Then in here you have the aircraft type. Okay, in this case it's a Boeing 737. In your case you will have probably an Airbus A320Neo or any other flight type. Of course, the data is consistent with the aircraft type, as you might imagine. Here is the route, the departure. Okay, runway 7, the elevation, feet of the aerodrome. Here you have arrival airport, the arrival runway 18 right, and the elevation in feet of Madrid, nearly 2,000 feet. Here you have a Mach number and the cruising flight level 340. There is kind of they are telling you that the fuel calculation that the software has performed has an error of 8%, right? For instance, we are not considering any wind in our calculations. You could include winds, but we did not. And here you have great vertical distance between the 2 aerodromes, the flight plan distance, and the aerial distance considering wind, which in this case, because wind 0 is the same. You have an alternative aerodrome, right, which is Valladolid, and with an elevation and the distance to the main aerodrome that again you can include in your flight plan. Here in this other block you get all the information about the weights. Okay, number of passengers, cargo, total payload, right, and the maximum payload. Here the 04 weight, the takeoff weight, and the landing weight. And this is something that you need to include in your flight management or the multipurpose control display unit, the MCDU. Here is the takeoff data, including the conditions. This is the takeoff weight, runway is going to be dry, temperature, and QNH. Again, this is you should probably take a look at the most recent meter. Flaps, the flex temperature. This is some sort of cheating the engine with a higher than existing temperature, right? And this is something that you can also include to increase performances of the engine just for the takeoff. Speeds, V1, V rotation, V2, and the same for landing. Okay, as you see, this has been computed in a non-existing or non-real weather, so we are just considering standard conditions, but you should check what the current conditions in your destination aerodrome are, QNH, and temperature, and here you have the configuration for arrival, flaps, and the reference approach speed, right, which is something that we are going to include as well in the MCDU. Then if there is a follow-up, missed approach in your chart, you should of course be having with you the instrumental departure chart and route chart, the approach and final approach chart, and here you have sort of trip fuel, all the calculation on reserves, contingency fuel, alternative airport, and the total reserve fuel that you need to incorporate, plus taxi, and this is calculating somehow the arrival fuel that is estimated with this arrow we've seen before. Here you have information on the fuel tank, right, which is the maximum, minimum, and here you have kind of the climb and descent profiles, right? 250, 280, 78. So cast 250 till 10,000 feet, then we will accelerate at 280, and then whenever we have a Mach of 0.78, we'll apply a constant Mach 0.78, and the same in an inverted manner for descent, similar to the speed profiles you have in your flight plans, the ones you did. Here you have information about the times, estimated time of departure, estimated time of arrival, takeoff, landing, estimations in time that of course are just for your information. Here is probably the most important aspect of the operational flight plan, which is the route. Okay, you have a kind of seed, right, a waypoint in the already in route, then an airway, another waypoint, airway, waypoint, and then the start arrival. You will need to select, of course, the ILS, and this is supposed to be consistent with the operational runways in use in the airport, right? But if this is not the case, you should be able to change your route accordingly. Similarly, if you are imagine the IRAC cycle gets updated and the information you have is old-fashioned, you should be able to update your flight plan and check it with what check what we have provided to you with what the information you have. This ATC, the route, it is kind of expanded below, right? Here you have the alternative planning, okay, and here you have all the information on the different waypoints of the route. Okay, so you get the departure, this airport, this is the altitude, minimum sector altitude. Here you have winds in this column, which you see 0 always, the tour speed and the ground speed, right, which you see that is 453 at some point, right, because this is VAST 7 Echo, right, this is the seat we're going to be following. Here you have this is, I don't know exactly what this is, empty, the magnetic track. This is the magnetic track you're following. This is the phase, right, climb, then you are reaching flight level 340, sorry, this is the leg, the distance in the leg, 31 nautical miles, and the remaining, right? So you'll see that you have kind of distances between two waypoints and what is remaining, fuel that is remaining, and fuel that is used. So we start to 10.1 remaining and use 0.1, and at the end of the flight you'll see that we have something like 3 remaining and 7.1 tons of flight, or kilograms of tons of fuel use. Okay. If we go up, here you have information about the elapsed time from takeoff. Okay, more or less it gives you information: 3 minutes, 8 minutes, 12 minutes, and so on and so on. Okay. No, it's sorry. So yes, this is the duration of the leg, 3 minutes, and this is the accumulated duration of the flight. So 3 minutes in this leg, 3 minutes in total, 5 minutes for this leg, 8 minutes in total, etc., etc., etc. So this is the information we are going to incorporate in our MCDU to fly with our Airbus A320Neo. So let's go and let's go on board and try to fly this. Okay, so here we are in the flight simulator, in the main screen. We have in our options everything is reality. Okay, so we are trying to fly as much closer to reality. So let me get back to the main screen and let's go and try to fly. First of all, let's select the Airbus 320 Neo. Okay, this is the one, and then we go to our runway. Sorry, Tenerife Sur. It is runway 07. Of course, here in the game we are kind of already selecting this, and this is going to be connected with the MCDU, as you're going to see in a second. In real life, you will need to include this in the MCDU. And in Madrid, we need well, let's do this, and we will change it thereafter. Okay. So we have our Airbus 320 Neo. We have origin and destination, and I guess we are ready to fly. Right. So let's click here, and we'll in 2-3 minutes we'll be ready to fly on board the aircraft. Okay, it seems that it loaded quite quick, and we are ready to fly. So let's go. Here we are on board the aircraft, right? We're gonna focus first of all on just programming our MCDU. Okay, so let's quickly go through. Here's where here's the left Lima 1, 2, 3, 4, 5, 6, and Romeo right 1, 2, 3, 4, 5, 6. Right, I'm gonna go Lima and the number, or Romeo and then the number to refer to this. And first thing we see is that we have the Airbus 320 page with the engine type, and very important to check what is the IAC cycle in place. You see that this is the one that is valid for November the 4th to December the 1st 21, so it's up to date. And we're gonna go through the different menu pages right here. So the first thing we can do is in any time during the flight we can ask a direct from where we are now to any of the waypoints in the flight plan, or any waypoint that you can create yourselves. Now it's not available, but at the end, once we load the flight plan, we'll get back and we'll see that we have more flight plan, more waypoints available for us, right? So this is useful in case you have any problem, in case you need to do a go around that should be somehow coded already in a secondary flight plan, but in any case it can be useful. Then we have the program. Okay, here is we have information about updates. If you want to report to ATC, you can include here a waypoint or information bearing or distance to a given waypoint to do a report. We have here information about the GPS in use, right? Detected satellites. Right now, no one. This is something we are not gonna be paying attention at. We're gonna assume we have our inertial reference system synchronized and our GPS working, and we can navigate. But this is important in RNAV to do this synchronization beforehand. Okay. We also have accuracy estimation. GPS primary is working, right? So we have this information in green, activated, and we could in principle modify the required distance. I am not sure what this means, but in any case, this is a programming page, right? Just one. Then performance. This is where we are able to modify the performance of the aircraft. We have the velocity of V1, the rotation V2 in Lima 1, 2, and 3. And if we check the operational flight plan, which is going to be given to you, please check it because I am not going to be moving between one or the other. We see that our V1 is 142, so we go 142 and click it here. In V1, in Lima 1, the V rotation is 143, right, and the V2 is 149. There we are. Okay. Then here you have the transition altitude that you should check in the chart whether it's 5,000 feet or not. I don't have the chart with me right now, but please check it. And here this is information about when the thrust reduce or the acceleration it's finished. Okay, at 1,700 feet I am supposed to start the climbing phase. This is what this is telling me. Then if we go to the center, information in the center, this is on green, so I cannot change it. Flaps retracted at 134 knots, slats retracted at 174, and this is the green dot speed that I have the feeling that this is incorrect because it should be higher than this, but this is kind of giving information in the displays, in the primary flight display, in the navigation display to the pilot. Here we have runway 7, okay, for the departure airport. Here is this is field in which if you are not departing from the threshold and you are departing from an intersection, you can include this information in meters, right, to tell that the aircraft that you are actually you have a reduced length of the runway. Information for the flaps, and then here's the flex temperature. Okay, the flex temperature in our case was 32 degrees. This is just to cheat the aircraft and to tell the vehicle that temperature is higher than existing ones so that you get more power. And we can click just here next phase. Okay, I am not going to go into details on each of the elements. I'm going to give you a reference where you can check kind of through manual of the MCDU, and if you're interested you can check more information. Here we will go to the climb phase. Here you'll see information on time while flying. Here is the cost index that we're going to set to 30, but I cannot do it here because the cost index is changed in the init page. So I change it there, and now you see that the cost index is 30. I can have the aircraft mode can be managed or selected. If you select here, right, a given speed, then you will have this will be changed to selected instead of managed, and you would have the velocity that you have selected, etc. This is green. You cannot change it here. The only thing you can change is the cost index. If you tell the aircraft to fly cost index 30, it will do it like this. Okay, we keep going. Same for cruise. You have just the descent cabin rate minus 350 feet per minute. That's a standard here. Same type of information, right? If you tell the aircraft selected mode, selected speed, it will appear here. same for descent. And finally, for approach, you have more information. You see now the speeds are kind of consistent, flap retracted, slab retracted, clean. So this is information that is useful for you to check when you need to start retracting flaps, slats to reduce your speed at approach. The QNH at Madrid, I don't know, but let's say it's a 1009er, right? We set it here. What is the temperature today? It's probably cold, so let's see, it's 11 degrees, something like that. I don't know. How wind's blowing? Let's say it's coming up from the north, so from the south, because it's we are departing 18, so it's a 180 slash, say we have 14 knots, right? So we can include here the transition altitude in Madrid Barajas. It's not 5,000, it's 13,000 feet, so we can include it here, and the approach velocity, which is in the operational flight plan, let me grab it, is 141, right, in our operational flight plan, so we can include it here as a reference. Okay, here we could include the minima decision height, maybe is 200 feet. Okay, we're going to fly an ILS approach, so we can include here the landing configuration, that is green, is has been selected by the aircraft, and that's all for approach. And then we can click next phase, and we could also program here the go around, which has not been programmed, okay, in this case. Good. This is just for performance. To initialize, sorry, you have two pages, right, 1 and 2. So here you have information about the company route on Lima 1. We don't really care. The alternate company route, here you have the fleet number. These are things that we are not very interested. The position, because we have the GP, the primary GPS working, we should check that our position is consistent. The cost index that I have just changed, and here we can change the cruise flight level, and even the value of the tropopause. In our flight plan, remember that our flight level was 340, so we will go Foxtrot Lima 340 slash, let's say we are in a minus 50, right? Something like that. And here we could include winds. It's not habilitated, but in a real MCDU you could get into this menu, sub-menus, and incorporate winds aloft at different flight levels for different conditions. This is relevant for the computer to calculate weights, to calculate fuel consumption, and to provide more accurate information to the pilot. If we go to our the next page, we see information on the amount of fuel that's going to be burned during the taxi, right? The trip and time, we still have nothing here because we still have no flight plan, so we need to do that. And you have kind of a bunch of information on the alternate, final versus, so distance times percentage of fuels to the alternate, to the final destination, etc. Okay, when it comes to the right hand side, we should know that in here we have the menu for our fuel, right? And we can load more or less flight, and you see that things are changing, right? In particular, we have the block fuel, which is the fuel we have on board the aircraft. This is in pounds, this is in tons, okay? So be careful with that. And we can also modify the zero fuel weight, which has to do with the operating empty weight plus the payload that you know, and the center of gravity of the aircraft in zero fuel weight conditions, and we can include this in here right? The block stays according to what you load, and then the takeoff weight, landing weight gets modified. Okay, so you will need to load fuel according to payload, according to these type of things, according to the operational flow. All right. Now, these are the 2 pages of the initialization. Then, when it comes to data, we can monitor the position of the aircraft. Right here, you see that we have the 3 inertial reference units plus the GPS providing us the position, and well, I mean, we should check that everything is consistent. If we have a GPS as primary navigation device, here we cannot monitor the information of the IRS and GPS. We just monitor this position here. Okay, whereas this is here you have closest airports, the communications. This is the aircraft status, which we have already seen. The database is very relevant, the type of aircraft, and here you will also see equipment. Here we cannot access these 2 panels, right? But this information that for us is not going to be very relevant. And then we move into, well, before going into the flight plan, I'm going to quickly review these menus, and we're going to be going to the flight plan. We'll be ready to fly soon. So the radio navigation is something that you have already done when flying conventional. You need to incorporate the VOR name and frequency, number 1, number 2, number 1 to the left, number 2 to the right, the course rate that you want to follow, ILS frequency, etc. This is going to be useful when flying instrumental, when flying conventional. For RNAV is in principle not needed, but it's always good to have this information in the background to double check where you are and do a role of supervision, so to speak, right? So it was good that you also have your navigation aids in front of you, and you tune the frequencies to keep track and keep monitoring the progress of your flight, even though the computer is going to be doing the job for you. Here you could have the fuel prediction, right? You could do alternative, you could do a lot of things. We are not going to go into details. This is the secondary flight plan, which is something that is useful to copy and move to the first officer's FLC or MCDU, and you can also try to, if you want to do a go around, or you need to do something in case of emergency, you can have kind of 2 different flight plans. You can activate one or the other, but it's good to have this. Then ATC communications, the menu, and the airports. These are things that we are not going to be using. So let's move into the flight plan. Okay, flight plan page. As you see, we have the origin airport and the destination airport. Nothing in between, so we have no flight plan yet. We can move with these arrows up and down, scroll up and down to see what's happening, but we still need to fill this in. So departure, yes, which runway 7. Okay, so I click, I wait a bit, be patient, and then all of a sudden I see the options in the Lima selected buttons. If I go down, I will get to Baste 7 Echo, which is the one I want to load. Okay, important color coding again. Blue is what I can select or change. In this case, it's the navigation database is providing me the information. Should be consistent with the information you have in your navigation charts. And yellow means that it's still not activated. Okay, it's kind of temporary. This is a temporary flight plan. Check here. Right? If I insert this, I am not going to do it, but if I would be inserting this, then it will become green, and it would be then incorporated or activated or executed in the MCDU. By now, I have selected this. I get back, or I go back to my flight plan, And now I see that from Gran Canaria I follow 10R, Golf Delta Victor, Laris, then Sarai, then Basto, and then to destination, which is Madrid. If I click the destination, I need to click the arrival. The arrival, I'm gonna do the 18, I think it's 18 left or right, I don't remember which is the runway I was provided. Let's do 18 right, the ILS uniform. And you see I can select no star, or I can try to check the stars, and my star, the one that I have in my ITC route, please recheck it, it's SOTU 6 alpha. So I click SOTU 6 alpha, I wait a bit, and they propose me via Lure or via Rico. In my flight plan, if you check it, right, not the kind of compressed route, but the waypoint by waypoint, I have Rilco, right, as the probably initial approach fix for this one. So I click Rilco, and in principle I am done. You can see with the flight plan that we start from Gran Canaria, right, Tenar, Laris, Sarai, Basto, Sotuk, waypoint in Madrid, Tuni, Rilco. This is RNAV waypoints, and down to runway 18 right. What type of things can I do here? If I click, for instance, I click clear, you see that it's here, and I go clear Rilco, it should be clear now. No, it's not. So clear Rilco. Now yes. Okay. Probably I did pressing another. So I have clear a waypoint. I want to add a waypoint between, I don't know, after Sarai. Okay. Basto. So Sarai, Basto, and after Basto there is nothing, right? So I can include, for instance, I'll check this, Basto. I can include, for instance, Parca, because I have removed more than one waypoint, because I removed all the connections. So Parca should be somehow here. Then I include here. Which one? Well, it's I guess, oops, this one, right? This is the only one that is possible. So I have Basto, Sarai, Laris, Parca. You see that now I have the UN 858. I can include Sotuk now. Sotuk. I mean, it was correct at the beginning, but I'm trying to show you how. And then I include here Sotuk. So now I want to include now LEMD, Madrid Barajas, after this one. the airport. So you see it's looking in the database and suggesting us options. So I have my flight plan. Destination, no, Lima, Echo, Mike, Delta. I don't know what it is. Destination now. I have cleared that and I have destination LNT. So now I review my so I'm going from Tenerife Sur, Tenar, Laris, Sarai, Basto, Parca via Union 884, and then probably after Parca I need to include Sotuk, which I have removed it. Sotuk, but here and now it's Sotuk via Uniform Zulu 165, and if I go destination I can get the again I have to do this, okay, but I have already done before. I get my Sotuk via Rilco and I'm done. So you see that I have done the flight plan twice, just to show how to clear waypoints and how to incorporate new waypoints. You can also go to Tenar and incorporate the next waypoint or new destinator. You can do a hold, then fix information, airways. You can do many things, right? You can include the speed and altitude constraints. In principle, the navigation database already incorporates some of those. And once I'm ready and I can check the information which is in yellow here, okay, always go to plan, okay, in the plan to check this, and here you can check you can maximize this, okay, if you want. Let's keep it in 10 nautical miles. Here I am. I want to visualize the plan. It is still in yellow, right? And if I go back to my FMC and I go and click here insert and I wait a little bit, you see that everything turns into green, and I can now check my waypoint, my flight plan that goes from Tenerife Sur, runway 07 via Basto Parco and down to runway 18 right. I can now see if I can do this. It's not that. Let me just, you see that I have, let me see if I can do this. This is important because I need to check for discontinuities, okay? So if I move here, sorry, departure, and you go one by one, Tenar, a flyby, Laris, Sarai, Basto, Parca, Sotuk, and then you already coming to the standard arrival with way more waypoints, probably an RNAV approach, and in the end you arrive into the runway. So you see that everything is continuous, that there are no, in principle there are no discontinuities. This is important because if you find discontinuities, then you will have a problem down the road. So you need to check this is indeed consistent, okay? So in this at this point we would be ready to depart. Okay, we would then probably need to select a speed of 165 maybe. Okay, select this speed for departure 65. Okay, I push it, so I give it to the aircraft. I want you to fly this speed. The heading, we are at 0.7 runway 7, so it will be 73, aligned with the given nav 8. Okay, so again I want to keep to tell the autopilot to fly up to 10,000 feet. The flight director is on. The auto throttle, probably I need to see and check that we are within the auto throttle to see if we are in a reverse mode, in a reverse domain. It does not allow to engage the auto throttle. Now probably yes, it's activated. We will then fly and engage the autopilot once in the air. Here we can visualize the VOR. It has not been synchronized, but we will need to do it. And basically I think we are done. We can check flaps 2. We could have a sway code, brakes. Here we have the auto brake maximum on. Landing gear is down, of course, because we are on the ground. And here we have the primary flight display. I would go Bravo to update the weather. Probably the weather is not real, so if I go here and I click on real, okay, now you see that QNH is 10:15. If I go Bravo, it updates to the real one. And my understanding is that we are ready to fly, so we can probably come here, start to accelerate and depart. Alright, so let me just move the parking position and accelerate. Okay, we'll go to the maximum, check our primary flight display. You see that we have the velocities we have indicated V1. Oops, we might be here. I was loose. We are now all ready to go in the air. And we engage the autopilot. And we can now see that we are flying. Okay. Speed is increasing. We would probably need to go down again and increase our speed. And now I want to move this to follow the. You see now that this is in a solid line, and it was not dashed because I have disengaged the other control, and now the aircraft is flying following the route that has been provided to it, right? Turning and following what I have provided to the aircraft. Okay, I am not gonna do this for flight, but we are already flying. We should now keep track of the management computer, information that we have, right? What we are climbing, the data we have, the flight plan, and check that everything is consistent. Always keep track of here of the right where we are, our next waypoint. Here we have winds. I mean, everything is going smooth. So thanks very much for your attention and enjoy flying. Bye bye.